Assalamualaikum warahmatullahi wabarakatuh. So today I'm gonna show you some solution and solve the problem with this case study, which we need calculate the tower height using k prime ya, k prime xa, and also with k prime ya. So basically we need to find the right equation for the appendix to calculate the height tower using these three different methods. First, we need to find the height tower using small k prime ya, where we need to use the right equation that using k prime ya, which is we need to find the value of z, which is the equation is vav multiplied by y1 minus y2 divided by k prime ya multiplied by s multiplied by y minus yim. So the value of y1 and y2 is basically from the metric balance from the equation. It also same with this value of k prime ya, which is 3.78 multiplied by 10 power of minus 2. So basically we need to arrange the equation so that it's easier to make unit cancellation, and we have the answer of last answer for the calculation, which is 1.946 meter. So for the second question B, we need to use k prime xa, where the question to calculate the value of z is not same as the first question, where the first question we need to use vav, while the second question is we need to use lav. So the equation is lav multiplied by x1 minus x2 divided by k prime xa multiplied by s multiplied by si minus xm. So the value of k prime xa is the value that also given in the question, which is 6.16 multiplied by 10 minus power of minus 2. So again we need to rearrange the equation like for the first question, and to make it easier for the units cancellation, and then we can get the final answer, which is same for the first question, which is 1.946 meter. Okay, so for the next question is we need to use big k prime ya, where you need to use the right equation of pack absorption column, where you need to calculate y minus y star m, y minus yim, and also y minus xim. So basically y minus yim and y minus xim is actually have calculated previously before the question of A and B. So the value of k prime ya and also k prime xa also had given in the question, and wherever this m prime is actually the value for gradient of equilibrium slope, which is in the question also, which is the value is 1.186. So then we just need to calculate it this and using this equation, and we need to get the value of k prime ya. So this is the value of k prime ya, which is 44.962, and we just need to substitute this value into the equation so we can calculate the value of z. But before that we need to calculate y minus y star m first. To calculate y minus y star m, we just need to find the equation from the appendix, and this is the equation where we need to find y1 star and also y2 star from the graph, where y1 and y2 value is just need to find from the equation given from the metric balance. So I will show how can we get the value of y1 star and y2 star from the graph. So how we can get y1 star and y2 star from the graph is y1 star value is based on the point 1, where we need to just drag the line onto the equilibrium line, and we just need to drag it to the left, and that's how we can get the y1 star value. So for the y2 star value is we just need to get it from the point 2, and same as the y1 star, we just need to drag it down to the end, and we can get the value of y2 star, which is 0. So after we get the value of y1 star and y2 star From the graph, you just need to put the value, which is 0.076 and also 0 respectively, into the equation. Then we can get the value of y minus y star m, which is 0.01028. So this value and also k prime y a value, which is 44.962 and also 0.01028, we need to substitute this value into the equation so we can get the value of z. So to calculate the value of z, make sure that the VAV is standardized with the mass of coefficient. And again, we need to rearrange the equation for easier to make the unit cancellation, and we finally get the final answer, which is 1.934 meter. So this answer basically is almost similar to the first and also second question. So wherever you using these three method, you can get the similar or almost similar answer, which is 1.934 or 1.964.